My name is Ryan Darrow. I am the founder and CEO of a marketing consultancy here in Cincinnati called Mostly Human, which therein lies our philosophy on the use of AI and machine learning as well, Mostly Human. I do also own Partly Human, just in case I'm hedging my bets incorrectly for the future. So, we do marketing consulting work specifically in the realm of advertising, of digital marketing, and of course in analytics as well.
And I'm Jeremy Henry. I am the head of the data practice at CoStrategix. We're a company just up the hill in Blue Ash. We do data solutions, things like data warehouses, data lakes, but also solutions that use data, so AI and ML.
So Jeremy and I have worked together on a few different projects, even though we're with different companies. And the goal for today is to walk you through one of those rather complicated projects that we just recently have started to finish up on. However, before we get into some of those specifics, I want to set the context really for what we're talking about a little bit more. And that context is around advertising. And this, after all, is a follow the money themed conference. And there's a lot of money that is spent in the realm of marketing and advertising. $455 bajillion, in fact, just in the US alone. This is definitely very, very big business. And it's not just big, follow the money style big, it's actually important business, not only for the companies that advertise and therefore grow their own revenue, customer, employee counts, but also for the US economy as a whole. So this study was done that pulled the total volume that advertising drives in the US gross domestic product is actually about 18.5%. So without advertising, turn it all off, turn all your ad blockers on, suddenly the US economy, well probably not suddenly, but over time, goes down by 18.5%. This is by far the biggest of such studies. The Eurozone, just for perspective, is about 7% of their gross domestic product is driven by advertising, whereas in the US, it's almost 20%. Big volume, big business, it obviously matters a lot. Yet, one of the quotes that's famous for the past 125 years from our friend John Wanamaker, who was an advertiser back around the turn of the century, last century, is still as true today as it was back then. And that's that half the money I spend on advertising is wasted. I just don't know which half. I don't know what half. 125 years later, that is still true. It's kind of sad, given all the newfangled technology and AI and all the access to data and data lakes and warehouses that we're talking about here today. But yet, I don't know what my advertising is specifically doing for me. So why? Why is that, you might be wondering? And really, there's two things. The language that we use really has kind of two different paths that we cross. There's traditional media and then there's digital media. So traditional media, which are the ads that you see on things like a television, or as you're driving down the highway and there's those boards on the side of the highway, traditional media has a historical problem of not really churning out a lot of data. So when we watch television, like broadcast television, that ad is sent to millions of houses within a market, potentially the entire US at the same time. We don't know within those houses who's sitting around and watching the TV. We don't know if there's one person, if there's 0 people, or if there's 4 people. So it's a historically limited data set. And then think about a billboard. As you're driving down the road, there's a big billboard outside the door, outside your car door, I should say, not your house door. You're driving by, you don't stop and go to the website, hopefully. You don't take a picture of it. So there's limited data churned out by traditional media. But we've known that. That's been that way for 100 years, ever since Wanamaker was around. The other truth is that there is less and less traditional media and more and more and more and more and more digital media going forward. And that's always going to be the case. Eventually that digital media will become virtual media, but it will still be digitally delivered. And the problem with digital media is that digital platforms lie. They lie. Google lies. Meta, which is the parent company of Facebook, Instagram, WhatsApp, they're liars. TikTok lies. LinkedIn lies. Instagram lies. Amazon lies. All of these digital platforms lie. Does anybody work for one of those platforms in this room? I should have asked that question before I told you were liars. They don't mean to lie. They just don't have the complete view. Google doesn't know what Meta's doing. Meta doesn't know what Amazon's doing. Amazon doesn't know what Roku's doing. None of them see each other, which means the data that they give us as advertisers, or those working with advertisers, is faulty. It's faulty. So Jeremy and I worked on a large project for an advertising agency with a couple hundred, actually a few hundred clients across the United States. These are the problems that they are trying to help their clients tackle every single day to prove to their clients that not only is their advertising working, like Wanamaker said, but specifically what parts of their advertising are working. So let's talk a little bit about these digital platforms and their lives, just by way of an example. This is from an apparel client. This apparel client is selling on Shopify. It's what we call a direct-to-consumer advertising. Most of their ad spend really falls in the two largest ad platforms, which is Google and Facebook. Google owns YouTube and obviously search and a lot of other display inventory, which are like the little banner ads that follow you around the internet. And then Meta, as I mentioned, is Instagram, Facebook, WhatsApp, and Messenger. So you can see here, just to unpack this chart for you, there's an in reality bar. There's Shopify's view of the sales that are being attributed to those different channels. And then there's the platform view. So the platform view in Google thinks that it sold almost $400,000 in this time frame for this apparel brand. Shopify thinks that Google sold about $250,000 in this same time frame for that apparel brand. In reality, Google only sold $150,000. All accurate data, only one of them is true. And then look at Meta. Meta, platform view, $250,000 compared to Shopify, and in reality, they're pretty close in this example at around $100,000. So they're over-attributing, as we would say, the impact of those advertisings depending on the place that you look. Another example. This is a consumer brand. Another DTC example, because these are really easy to tell stories around because the sales channel is immediate. So this one also sells through Shopify, so it's just a digital website. This one's been around for a little bit longer. They have more repeat sales from their customers. They have more word-of-mouth referral business. They actually have more marketing channels in the mix. And you can see the story here is even more stark in terms of how much the platform data lies versus what really is happening in terms of driving attributed sales for this advertising. Almost 6x higher to that extent. So look at the in reality, the dark blue line on top for Google and Meta, versus the platform views, which are 600,000 versus less than 200,000, and then almost 1.2 million versus actually only 225,000 in reality. This is an AI and analytics conference. What if we drop AI directly on top of that data set, on the platform data set, or even on the Shopify data set, and then made all of our decisions based on that because we got AI? It's horrible. It would be a very bad outcome for the advertiser. They would vastly overspend what they should be spending and not get enough returns. They'd be bankrupt. Our CTO friend from Fifth Third in the previous session just made a really smart comment on the panel that you can't just put AI on top of raw data. You have to put it on top of curated data. So we're talking today about how we've curated some of that data for an advertiser with a lot of clients across the US. So what do you do when platforms are accurate? They're liars, but they don't need to lie. The data's accurate. They can point to it. They can transparently give it to you. It's just not correct. So what do you do when it's accurate or incorrect? The old college try, if there's any students in the room, you do the best you can, and you do it with the best data and analytics available. So there's really a couple things that we are helping this particular client introduce by way of data and analytics. The first is incremental measurement, which is really well depicted in that very simple graphic there. It's just, if I do that thing, that one thing, call it Meta, call it Google, call it YouTube, how much more business result do I get from doing that thing? And we'll talk about the couple different ways to measure that. There's many, but we'll talk about 3 of them. And then relative performance, which is to say, I don't necessarily need to always know exactly how much dollars I'm getting from exactly how much I spend. I can sometimes just get away with doing better if I know how well I'm doing versus competitors, versus benchmarks, versus year ago. There's relative dynamics that still can make me improve even if I don't know the absolute dynamics. Okay? So on the incremental measurement side, one of the first and one of my favorite things to help advertisers and agencies understand is how to set up an easy experimental design where we're creating a test and control environment We're trying to balance the test and control environment as best we can with all of the data that we have available to make sure there's no noise in the system. And then we're simply deploying the treatments in the test areas, and we're not deploying the treatment in the control areas, and we're watching some discrete data to see if that test drove an incremental impact. So did turning on YouTube for 8 weeks in Cincinnati help my business? Yes or no? It should be a simple question. Experimental design is one. Another good one is diminishing returns. So let's keep going with my YouTube example. Maybe this week I spend $100,000 on YouTube. Maybe next week it's $200,000. Maybe the week after that it's $300,000. The week after that it's $400,000. Then I go back down to $150, $250, $350, $450. I can change the amount of money I'm spending on an advertising channel and get a lot of different data points to put on a scatter plot to then put a curve around to see, okay, where does my spend stop giving me more sales as a result? And that's the point of diminishing return. So not only have I then figured out the equation for how much I spend gives me how much in value or volume, but also where should I stop spending? So that's another nice incremental measurement tool. And then the gold standard that we use the most often for our clients, which requires a lot of data, is marketing mix modeling. Are you familiar with marketing mix modeling? A lot of nods, some half up hands. It's just the collection of a lot of data on a very regular cadence, like weekly, and then you tie all that data together with analytics and stats to say, when I do these things over here, does my dependent variable like sales or traffic or leads, does that go up or down? And if you look at a long enough period of time, like 2 years, for example, 104 periods of data, with all of those different marketing channels firing, then you can get a pretty good mathematical representation of the real answer for incrementality, versus how much would it come anyway, versus how much was driven by word of mouth, versus how much was driven by external factors like macroeconomics or tariffs or whatever might be going on. So incremental measurement is great. That's the best that we want. However, we can't always get the best that we want because of data availability, so relative performance is also good. The easiest example of relative performance tool is data visualization. Once I take all that data in raw form and I put it in a chart, I can see that that blue bar is higher. And higher is good because I want to drive more money for my clients. So that is the simplest way to think about a relative performance tool. That thing is higher than the other things. Another way to think about it is via benchmarks. So again, I don't know if my return on ad spend, that's ROAS, return on ad spend, if $3.44 is exactly accurate because digital platforms lie. But I do know that my $3.44 compares to a benchmark of $4.25 return on ad spend, which means this client is underperforming by way of that benchmark. So again, I don't need to trust that the 344 is 100% accurate. I just need to know that I need to do better. And then what more can I do to do that? And then finally, just trending the data. So how do I look at things over time? So if my 344 is that way this week, but it was 425 last week, maybe I'm not so concerned. It's not a trend yet, it's just a data point. If it's been 344 for a long time and it's not going up or down, then maybe I need to take action. So again, just looking at the data relatively versus an absolute is still very helpful for making marketing decisions. And in the case of our shared client example, helping their clients make more money. Driving that US GDP, one ad at a time. Okay? But in order for us to get to these kinds of solutions, we have to wrangle a whole lot of data first, which is where Jeremy comes in.
Yes. So I'm going to talk a bit about kind of the nuts and bolts, right? The data's out there, but you got to get it into a place where you can actually use it. So that's the job of the technical solution. So that's kind of my side of the solution. And it's making the data discoverable, usable, and accessible to the right people and in a secure manner, right? That's the job of the technical solution. So first of all, what data are we talking about? So what we're really talking about here is, again, this is digital marketing data, right? Digital sales data, digital ad spend. These are the types of things you would find in Facebook, Meta, Google Ads, LinkedIn, Simplify, etc. There's a lot of these possible ad platforms or analytics companies that are gathering that data that the advertisers need. Now, the ad companies themselves are using like a marketing management platform. This is the platform that they use to actually make, coordinate the campaigns, do the ad buys, etc. And so they're interacting, those platforms are already interacting with your data sources. And some of those marketing management platforms will have analytics capabilities already, right? They'll have visualization or reporting, and if they do, and if that's sufficient for your needs, then great. Then you use that, right? That's already there and it's already available. The caveat there is that if these are kind of the canned reports or canned analytics that are available through that platform, there's a good chance you're doing basically the same types of analytics that all your competitors are doing as well. So it may be sufficient today, you may outgrow it tomorrow, right? So that's something to keep in mind there. At the point that you outgrow it, then you need to start bringing your data into a separate platform where you can do that type of data wrangling and some of the advanced analytics that Ryan was talking about. So, and these platforms, some of them, they can allow you to export your data directly out of the platform and into a data analytics platform, right, into a database. And again, if they have that and that's available and it's sufficient to your needs, then use it, right? That's great. You saved yourself a lot of data engineering. The caveats there are, one, it might only be a subset of the data that you really need to do your work, or two, there might be an upcharge, right? They may charge, the vendor for that platform may charge more for that data export. What we ended up in this situation was kind of we ran into that, so we had to go to call the APIs and the data sources themselves. We ended up with kind of a hybrid approach where we were able to get some of the data out of the platform, the other ones we had to call APIs and get it out of the data sources. So we're getting the data into an analytics platform. What does that look like? This is kind of a view of an overall foundation for an analytics platform. Over here you have your data assets like we just talked about, the data platform and engineering, that's the technical solution that I'm talking about. The data insights, that's your kind of straight up Power BI visualization, basic analytics. Underpinning all this off to the right, you have your data lifecycle management, your data governance. Governance gets into things like your policies and ownership. And then once you get your data, it's in a platform, it's being governed, then you can get into some of these advanced models like Ryan was talking about, as well as data products and services, right? So making that data available to third parties, monetizing it, making it available to like your clients and vendors. So I'm going to focus right here on this number 2, this data platform and engineering, and what we did in order to make that happen. So this is kind of a logical diagram of a data platform. Over here you have your sources. Here's a kind of a big black box. I'm calling it data cloud right now. That's what we're talking about. And then off to the right is, once we fill in this black box, we need to get that data over into the data insights where it can actually be used. So the question is, what's in this data cloud? So we're going to talk about the data architecture, the data tool set, and the data model. These are kind of 3 orthogonal concepts. They don't really depend on each other, but you got to answer all these questions before you can build your data platform. So first up, data architecture. My thesis is there's kind of no best data architecture, right? It really depends on the needs of your system, of your client, of your business users. You got to take that all into account. I've listed a couple of the more straightforward or popular ones up here. Things like a data lake, data warehouse, data mart. Data fabric, this isn't like MS Fabric, they've kind of co-opted that term for their own suite of products. This is more of that logical idea where you're kind of putting a virtualization layer across multiple cloud platforms. I haven't listed everything here, right? You don't see things like data lakehouse or like a Kappa or a Lambda architecture, data architecture. And these best 4, right, that's just my opinions. That's kind of the guidance that I use. What we ended up with for this particular project, we're just really looking at a data warehouse and a data mart. The data structured, we're getting it from the APIs, right, that are available through Meta and Google. So not a lot of need for a data lake, which is primarily for unstructured or semi-structured data. The data mart is nice because even though it's all marketing data, at some point you're going to want to bring in like finance data or HR data, things like that. You're not going to want to mix them and match them. You want to be able to keep that compartmentalized. Not necessarily silos because the data is still accessible across those boundaries, but at least separate it out so that you don't have your marketing people, having to sort through a bunch of HR finance data that they don't care about. We don't have real-time data, right? This is we're just pulling the data out via APIs. So things like a data hub or a Kappa Lambda, those weren't really relevant. So this is kind of where we landed. As far as tool set goes, similar. There's no best tool set. You can really kind of build any of those architectures using any of the technologies for the most part. So again, it really just depends on the cost, what your technical people are already familiar with, what they're comfortable with, and what your need is, right? What you're trying to build and what's the best in breed for accomplishing that. So here, the one nice thing though is the categories that make up your technology platform are becoming a little bit more codified, right? So these are things like your compute storage, right? Your database, or your pipelines, ETL, right? This is where you're transforming the data, moving data around. The MDM, so some of these aren't going to be needed, right? You wouldn't need necessarily a solver unless you're doing optimizations. So again, these are things where you can pick and choose. You can go and get any of these particular vendors to play a particular part. There are suite products like Fabric that kind of cover a whole bunch of these. That does kind of lock you in and prevent you from working with some of the best in breed, but it's nice because it's a single vendor and you can get a lot of capabilities at one time. So and I haven't listed like everything again up here, but this is kind of the main ones that we think about. The tool set that we eventually decided on was primarily a Microsoft stack. Microsoft Azure is the public cloud, the Azure Key Vault for storing credentials, Data Factory for pipelines, Power BI for visualizations. I did go with Snowflake here as opposed to one of the Microsoft products. And Snowflake plays really well with Azure. It runs on the same compute. The nice thing about Snowflake, well, again, you could choose different things. If you have a bunch of like technical people, a lot of Python developers, you can go with something like Databricks, right? Or the nice thing about Snowflake for us is, we don't have a lot of technical users. The folks are marketing people. They have SQL skills, but not necessarily Python. Snowflake we found is like the most forgiving database technology you can use, right? And especially on the SQL side, it handles almost any SQL command you can imagine. It's very forgiving. It doesn't, it's not case sensitive, things like that. So it's really easy to get the right command that you're looking for. And I haven't listed everything. Like there's file storage. You can use Azure Blob Storage, but these are the main ones that are going to make up your technical tool set. And then the third piece of this is the data model. So this is my most dangerous slide because I'm making a judgment here. I think there kind of is a best data model, and that's that, the dimensional model, the star schema, this is the Kimball idea. And the main reason there is it's just so many people are familiar with it. If you're not familiar with it, most people can learn it in a day. So this is kind of the one that we focus on. We focused on for this particular project. And if you're familiar with it, it's called star schema because you have your dimensions around the outside. These are the things that you would typically filter a query on, sort on, those types of things. In our case, that would be like your dates. Your account would be what brand you're talking about. Your ads and campaigns is a dimension, which platform, whether it's Meta or Google. And then some kind of a geographical dimension usually comes in with marketing applications as well. The facts in the middle are your marketing things, right? Like your clicks, your views, your impressions, and the purchases. That's the data that Ryan was just talking about that he needs in order to do those analytics. So there are alternatives, like third normal form. That's much more common in operational databases, transactional databases, not so much for analytics databases. Data Vault, OBT, those are great for analytics databases, but they're usually for special cases, large data, streaming data, things like that. If you don't have a need for them, then dimensional data modeling, star schema is a good option. So our data cloud's kind of taking form now. We have our sources that are going through this ingestion layer. They're going into a 3-zone architecture. This is a standard like medallion architecture with your bronze, silver, and gold. Your transformations are done in the silver, and then you publish them out in the gold. It's underpinned by these ADM pipelines, and then you're feeding the data out to the activation layer where you're getting your insights. I do want to focus on this part right here. This is actually a bit more complex in this particular use case than you would usually encounter. So what we're talking about here is that the ADF pipelines have to make API calls out into these sources. And if you're just one company, if you're just Home Depot, and you just need to go get your data from Google and Meta or LinkedIn, That's generally pretty straightforward. You're just making your API calls and you're good to go. But in this case, it's an ad company, right? And they do this for a lot of different clients, right? A lot of different brands, not just a Home Depot. And in those cases, I've only listed a couple of these data sources here, Google, Meta, LinkedIn. But in this case, there could be dozens of different data sources that you're having to access. And it's not just Home Depot, right? There could be hundreds of clients that this company is doing ad work for. And when you do that type of math, it becomes a bigger problem. If you have 500 clients across 20 platforms, now you're talking about 10,000 connections. And these 10,000 connections are not just like, well, what's the ID number? There's actually some additional information that needs to be maintained for each of those connections. Things like the source account, and again, the credentials are going to be stored up in like the Azure Key Vault, but you have to manage them somehow, right? Some human has to actually keep track of these, the information associated with this. And then the status, even though you have 10,000 connections, you're not necessarily doing analytics or these advanced analytics for all your clients, right? So you don't want to bring in data that you aren't using to do the analytics. That's just additional compute and storage that you don't need to pay for. And then historical load, right? You have to keep track. What all data have I brought in? What time periods, right? Because like Ryan was saying, it's that historical trend that becomes really useful. So what we decided to do here to help humans keep track of these 10,000 connections is we built a little client admin app that interfaces with our data cloud and then handles some ingestion and connection management. And you can see it's got a little database, right? So you could store that data in the Snowflake database, up in here where we store our actual marketing data. But keep in mind, Snowflake is an analytical database. So it's really nice in that if you're trying to get 1 million rows back, it takes about a second. But if you're trying to get 1 row back, it takes about a second. So that's not very fast for a client admin app where somebody's waiting on the other end trying to get their data back for that particular record. So we just boot up, it's really simple, we just boot up a little SQL Server database in Azure, and that's where we store that data. And then keep in mind your API pipelines are going to have to interact with this database in order to get the information they need to orchestrate the calls out to the APIs. So that kind of completes our technical solution. We have our data cloud, our admin app that allows us to manage the connections, and we have the data flowing through on a daily basis out into, you can see the star schema, the data marts, and we can push that data out to the data insights to help Ryan get the information he needs to do his job. So what are some takeaways, some things we looked into or learned along the way? First one, raw data, not necessarily the best data. Wheat is great, but I'd much rather have it processed or transformed into bread before I try to ingest it. Similarly with data, there's a bunch of different extraction methods and they exist along this spectrum. And down at the bottom here, you can see we have just straight up SQL queries into an operational database. And from in terms of ease of access and quality of data, it's kind of the worst of both worlds, right? You're having to, it's a rather technical endeavor to try to get that data out. You have to understand the data model, all the technical debt, the logically deleted records, all the rest. And then in the end, your quality of data is only as good as you understand that data model. If the data source provides APIs like Meta does, like Google does, great. Like I definitely want to use that. If they have reports, that makes it even easier, or extracts. And finally, we're seeing a lot of data share where these companies just make their data available in a Snowflake database. And you can just access it, join to it. When those are available, definitely use them. That's kind of the best option. Next, there's different kinds of marketing data. So digital ads, social, search, analytics. So these are all kind of distinct types of information. Now, what gets a little confusing is that they all kind of work on the same type of fact data, like clicks, right? So there's this idea that all of them have clicks, but do you really want to normalize those clicks out to a separate fact table, like a fact clicks? But that would be the same as taking a fact dollars table, right? All your dollar amounts would go to a separate table. That's really getting into normalization. Generally, you're not going to want to do that. There is some MDM type work, right, where you want to take the data from Google ads and Meta ads, and you want to combine that into a single type of ad clicks. but you're not necessarily going to want to try to normalize out the clicks themselves. What you're going to end up with is separate fact tables for each of these different categories of marketing data. So again, keep that in mind. Don't go too far on your MVM. Don't try to normalize the data. And then third, focus on that AI-ready data, right? So a lot of the conference today is talking about AI and AI-ready data. It's something you want to keep in mind, especially as you're building the data platform. There's a couple of points here. Again, this isn't a complete list, but things to keep in mind as you're building your platform. First up is accessibility. We talk to a lot of clients where they have these great AI ideas, and they say, we have data. And I say, great, let's see that data. Can we look at it today? And they're like, well, I mean, not today. It's not really ready to look at, but it needs to be, right? In order for your data to be AI ready, it needs to be provisioned, it needs to be accessible. It doesn't have to be co-located necessarily, but you do have to have that central access point where you can go and access that data. Your AI is going to want to do the same thing. You need to be able to get that data to where the AI can use it. Next up is quality. So the big one, there's a couple different characteristics of quality. The main one I worry about is completeness, right? Because what we see is there's a tendency to go get the easiest data, right? So wherever the data is easy to grab, people love to go and grab it and pull that in. That creates an implicit bias, because what you end up with is the training data that you use or the data that your AI is using is really only looking at the simple use cases, but you're trying to use it to solve complex use cases, right? So keep that in mind. Make sure that you're looking at all sectors of your data and you're not introducing those implicit bias. And third is metadata. So there's straight up things like where the data come from, what's the date stamp. That's useful. But anything else you can provide as far as those labels, tags, glossaries, data dictionaries, those are the things that are going to help your AI understand the context of your data. Now right now AI is pretty bad at understanding context, and it's going to get better. But at least for right now, the more information you can provide as far as things like labels and tags, the better off you'll be when you try to use that data for an AI use case. And as an example, if you remember this slide from a couple slides ago, an AI would really have a hard time understanding what the point of this is, right? So one of the things you can think about when you're creating your PDFs, your slide decks, or even your emails is try to make your point explicit, right? Just state it. You can put a title on your slide. Don't normalize your analytics data. Now the AI not only doesn't have to figure out your picture, but it knows your point directly, and it can start to learn, oh, that picture with this terminology means that, right? So now it's helping your AI to not only understand, but get smarter as it goes. So those are just 3 pieces of advice to keep in mind as you're working on making your data platform provide data to your business consumers that's already AI ready.
So then, once Jeremy's done with CoStrategix wizardry, then we can get back to the AI tools. We're not working with raw data sets anymore. They're going to give us as marketers and advertisers really bad information and cause us all to go bankrupt and the US economy to crash. We've got structured data now. We've got good data that we can run our analytics against, we can generate reports against, and that's exactly what we're doing now. So deploying the AI tools against those curated data sets, as the Fifth Third CTO said, that allows us to really be smarter with the tools we deploy. So using something like OpenAI, we might say, hey data, what are the benchmarks for video advertising in the retail advertising category? If I did that on the Google data set, or the Meta data set, or the Amazon data set, I'd get vastly different answers that would all be wrong. Because remember, they all lie. So now that we've got analyzed data that's talking about true incrementality, we can look at it this way. Or, hey data, how have brand XYZ's ads performed over the past 4 quarters? So again, just really simple, Gen AI tools that some, typically 25-year-old doesn't have to go through all this analysis to try to figure out anymore, because they can just ask a simple question to a simple tool that's either on their desktop or on their phone, or something like, how does brand XYZ compare to retail category leaders? So again, adding that comparative dynamic, looking at the analyzed performance versus other competitive brands' analyzed performance. How did I do? Like, am I winning or losing in this marketing equation? So once you've got the data in place, you've wrangled all that, then you've done the analysis, going through those incremental tools and those relative performance tools that I talked about earlier. then you can get to a point where AI is actually not dangerous, it's incredibly helpful, which is the point that we're at with our advertising agency client working across hundreds of brands. A little premature. So with that, do you all have any questions for Jeremy or I? Please.
Can you?
She raised her hand first.
So I'm curious, like when you showed your graphs showing kind of like the error of these platforms, did you ever like decided to maybe estimate? Is there a way to estimate maybe the error? Is there maybe like a common way to find, okay, most of the times they're wrong by, I don't know, probably like they're overestimated by 40%. Did you ever like decide to go towards that route?
Yeah, that's a great thought, and it's exactly what we do with mixed modeling for this advertiser in particular, or this agency in particular. What I will tell you is that across 1,000 different brands, that percentage wrong is different for each brand. And it's different for each brand depending on a lot of other things, a lot of the other kind of tools in their quiver. So if they are only like a 2-channel marketer, then it's easy to figure out what that standard error rate is and then just apply it like that. But it's actually different for everyone depending on how long they've been around, how many customers they have, how good a ratings and reviews they have for word of mouth. So then you have to calculate that, and then what we use the marketing mix modeling tool to say, okay, here's the real score, and then we tell the digital team to pull in those levers in Google and Meta, here's what you need to get to. So your $3.44 ROAS is actually only $1.80. So once you're above $3.64 on ROAS, then you're above $2 in reality. So that's where you want to get to. And if you get there, do more of that.
So the error is by brand, because what I meant is more like,
yes.
What if, let's say, Google Ads is 20% wrong for every brand?
Yes,
no.
I wish it was. That would make my job
that
so
would make
easy. I probably wouldn't have a job, but otherwise it would make it very, very easy. So that's a great thought, though.
Thank you.
Yes. Yeah, go ahead.
Yeah. So, like the stars one that you showed earlier on the slide, did not have customer dimension in that. So do you guys only deal with campaigns, or do you guys go at a deeper level to the customer? Because
Did you get that question right?
Yeah.
To know how Facebook, Google, and Meta share like customer information.
Yeah, that's great. So generally, the star diagram that Jeremy walked through, one of the dimensions that was missing from the outside of the star was actually customer data. The reason that it's missing is because in advertising, most of the data is anonymized. So the Metas, the Googles, the social networks of the world are what we in the industry call walled gardens. You can't see anything in, and they won't give anything out. So what you can do is you can send them data, but then they keep it. So they don't let you know which of the customers that you've sent them they're actually interacting with or we're advertising to, only in bulk, only in aggregate. So we don't, for advertising agencies, pull down customer data. For other clients where we're doing marketing that's more addressable, I have an email address, I have a postal address, I have a phone number, then we would pull down the customer data dynamics for things like email or SMS or website actions. But for this particular advertising agency in the anonymized world, it's not needed. That's a great question. Yep.
For the AI side of the consumption layer, did we ingest that curated data from the data warehouse we created into an LLM that was customized for the application, and then what AI tool was used on top of that for purposes of prompts?
Yeah, that's the work that's going on right now, post database completion.
Okay.
So we're using OpenAI models, and we're sending that actually to that exterior database that Jeremy showed you, the one that sits outside.
Well, how do you translate from that database that you made that's sitting on the outside through the LLM? You can't just show an LLM like, hey, here's a table, make a whole bunch of stories. Where are you at that level?
Say it.
So how do you translate between having your data in a table, that external table, and the LLM?
That's a good question. It's a data science question, and I am not a data scientist. Do you have the?
I didn't understand that question. It's the.
So we've got the it's the the client's AI usage that goes into OpenAI and queries that data, and then we store all those files in that external data set. So then how does that interact with the LLM is the question.
Yeah, I don't know that, yeah. Couldn't say that.
Magic.
Yep, imagine.
That's beyond the right side of the slide.
Yep, that's right. Yes?
Yeah, just curious, on your data platform, you had an admin control at the bottom. Was that a home built or
Yes.
homegrown app that helps you like scale it out for?
Yeah, that was just it's a small web app, and it's really only used for the folks that are dealing with client account maintenance. So yeah, there's only like 10 or 15 users of that total. It's a small app, but again, it allows that nice user experience, user interface to manage those 10,000 connections.
Well, if anyone has any.
He does.
How do you handle granularity in the walled gardens? Are you pulling out the lowest granularity data and then aggregating on the backside, or are you pulling it out in different granularities and different formats and different tables?
We're storing the platforms themselves don't work at individual user granularities, so we're storing it at the granularity that they provided. And I think this gets back to a previous question, but like the fact tables themselves, there's different fact tables for different user profiles. So when it's things like demographics, right, or age groups or geographic locations, there's separate groups, and then it's aggregated based on that, right? It might be aggregated by zip code for data that's provided there. But basically, we're storing it at the same granularity that we're pulling it out of the APIs.
Okay.
Just curious what your, at the beginning of the Mesh platforms that you were comparing in terms of how much they were overstated and such. I was wondering if you could go into a little bit about how you created the idea of the ground truth, what the incrementality actually was on those to your satisfaction, because I know some platforms make it extremely difficult to find something that you can believe in externally.
Yeah. So the real results that we talked about in those charts, those were actually from marketing response. So we actually pulled all the data out, we ran the regression analysis against it, we added the external factors, and then what we saw from that was from the mixed model validated with those experimental designs that I talked about as well. So that was post analytics, it wasn't from the platforms themselves.
So you actually found convergence between your MMM and your incrementality done through an experimental design, like I assume a synthetic control design or something?
Well, no, so what we actually do there is we do them as separate projects. So we'll run the mixed modeling, and then we'll run experimental design to validate the mixed model. And if we need to change some of the coefficients in the mixed model, then we make those adjustments to the next mixed model, if that makes sense.
Stable enough.
I was wondering in your data, the architecture of the data platform that you showed, what is the differentiating factor, or what is one thing that worked well for you?
One thing that worked well.
Yeah, just like, what is the most important thing that helped you to achieve the entire data architecture that enables the AI or whatever, the measurement platform? The biggest challenge.
What's the one?
The biggest challenge that you overcame.
I'm not sure I understand the question, but I mean,
In the data platform of the data architecture that you showed, what was the biggest challenge that you overcame to enable that?
oh, the biggest challenge that we faced was taking the ad data from folks like Meta versus Google versus LinkedIn and trying to get it into a common set of fact tables that would be common, right? So, and they all call it different things, right? They don't all call it clicks or views or whatever. They call it impressions or whatever else, right? There's a bunch of very specific terminology that they use. And being able to do that mapping from each of the data sources into a set of fact tables that would be common across all the data sources, that was probably the most difficult thing that we had to deal with as we built the platform, right? And then there's also things like, if there's things that only certain platforms provide, you have to kind of discard it, right? You can find a way to transform it, if you can, into something that the other ones also provide, but some data has to be discarded. So you kind of put like the subset of the available data that's common across all the platforms. So being able to figure out what that data model looks like, and then being able to do the mapping is probably the single most difficult thing. But once you get past that, it's standard data engineering.
So,
Yes, timekeeper?
I mean, you've got 4 minutes, but we're good. So in terms of how you're determining whether those clicks are actually converted into real sales, how do you take into account external factors that could impact revenue and make that sort of count more accurate to the actual impact that advertising or marketing is having?
Yeah, which is exactly the problem with Google and Amazon and Meta. They don't. So they don't know when you've bought before. They don't know when it's raining. They don't know when their competitors have shown an ad. So that's why you have to get all the data in and then do the marketing mix modeling, do some of those other incremental or relative performance tools that I talked about to get a better sense for what the true story is, because the digital data is wrong. Cool. So with that, please keep your ad blockers off for the sake of the U.S. economy. Thank you very much for your time.